We're now going to take a look at another type of array called the two-dimensional array. So far, we've talked about managing one-dimensional arrays, and these are great when our data is represented as a list. But what if our data is represented as a table? Well, if all the entries are the same type, then we could use the one-dimensional array approach. The problem with that is trying to determine the row and column of each entry would get messy. I mean, we can do it. We can organize our table as this giant array, but it gets pretty ugly. So instead, we can use a two-dimensional array. So here we have a collection of some fixed number of elements, just like a one-dimensional array, except now we can arrange our data in using rows and columns. And just like with one-dimensional arrays, all the elements must be of the same type. The way we declare a two-dimensional array isn't too different from declaring a one-dimensional array. So this is what it would look like. The only difference really is that we would have two square braces. So now we have 2 instead of 1. That's really the only difference. Now, this only creates the reference variable, so we still need to instantiate the array object. So we still need to create it. So the way we do that is, well, it's very similar to one-dimensional arrays, except now instead of just having our new data type and then putting a square braces for one dimension, we now need a second set of square braces and then an integer in there that would give us the size of the second dimension. So really the only difference is just we have this second set of square brackets or square braces, and we just need to set two sizes, one for the number of rows and one for the number of columns. Let's take a look at an example of declaring a two-dimensional array. So here I'm going to create an array called sales. Now I know it's a two-dimensional array because we have the two square braces right here after double. So remember, with one-dimensional arrays, we would just have one of those. For 2 dimensions, we need 2 of those. And then over where we have new double, we now have 2 sets of square braces here. The first one, the 2, would indicate the number of rows, and the 3 would indicate the number of columns. So this is the way we can visualize our array in this case. So now instead of looking at it as a one-dimensional array, just one long list, we now have a table that gives us the number of rows and columns. So this does create our two-dimensional array where we have 2 rows and 3 columns. And since we are dealing with a double array, just like with one-dimensional arrays, all the values in here would be initialized to 0.0. Now, to access any element in a two-dimensional array, we need a pair of indices. So we need one index to indicate our row number, and we need one index to indicate our column number. So the syntax of it is actually almost the same as a one-dimensional array. So we have our array name, some square braces, and then an index. But now we have this second one to handle our second dimension. So another set of square braces, and then our column index. And just like with one-dimensional arrays, these values, these indices, have to be non-negative integers. We still can't have negative dimensions. And we have to make sure that the row index is less than the row dimension, and the column index is less than the column dimension. Otherwise, you're going to have an index out of bounds, array index out of bounds exception. So we have to make sure that each index is within the appropriate bounds. Let's take a look at an example of accessing an element of the array. So still using our sales example, we can have sales 1, 2 equals 25.75. So what this does, it stores 25.75 in row number 1 and column number 2. That's it. So we can just work with indices directly, just like we would do with one-dimensional arrays. We can also have our indices be variables. So for example, I could have my I be 1. I can set a j to be 2. So we'll assume that I and j are already declared. And then I can do sales ij and have that equal to 25.75. So this also works. And just as we can with one-dimensional arrays, we can use the length instance variable for two-dimensional arrays. So let me give you an example of how useful this is. So let's say I create a two-dimensional array, which we'll call matrix, and it'll be an integer two-dimensional array with 20 rows and 15 columns. So what does matrix.length give us? It gives us the number of rows. Because if you can kind of think of this, think of a two-dimensional array as an array of arrays. That's how we can visualize this. So matrix.length will give us the number of elements or the number of rows for our structure here. Now, like I said, each row is an array in itself. It's an array in an array. So each element corresponds to another array. So matrix 0 would be an array. And since matrix 0 is its own array, it has its own length variable. So I can do matrix 0.length, and that's going to give me the number of columns. So we can use another index to get the number of columns as well. So we can do something like matrix 1.length, and that will give me the number of columns for my array.